Now let's say we have a scenario where we have a ball, okay, that is on a flat piece of ground, and we know that that ball was kicked with a velocity of off the top of my head, I'm gonna say 10 meters per second. Okay, and we know that the ball was kicked at an at a angle of 25 degrees. Okay, now in order to find my v initial x and my v initial y, we have to bring out some good old-fashioned trigonometry. Okay, so I'm going to call v0xa and v0yb. So let's solve for a over here. Okay, what we know at the initial point, there is a x velocity. Okay, the x velocity is right there. Okay, and as it goes through the air, it won't change because acceleration is 0. But we don't know what that is. But we have two very important pieces of information in order to find our v initial x. In order to find our v initial x, we have to use trigonometry. We see that we have the angle, or the theta, is equal to 25. And then we have our hypotenuse, or our velocity, as 10 meters per second. Okay, we don't have the opposite side, or the y, but we are trying to find v0x, and we can in fact do that. All right, we have here an adjacent side to that angle of 25 and the hypotenuse. Now, if you remember, adjacent and hypotenuse, that's part of cosine, or ka. That's the easy way of remembering. So ka toa, cosine is equal to the adjacent over the hypotenuse. Okay, so in order to find our v0x, we have to say that, let's get rid of that. We have to say that the cosine of theta is equal to the adjacent over the hypotenuse. Okay, now let's actually put in some numbers and some variables. We have the cosine of 25 is equal to the adjacent, which in this case is v0x, over the hypotenuse, which is just our velocity. Okay, and so in the next line, I'm just going to write down my actual value for the velocity. And we have 10. Okay, and I'm going to multiply both sides by 10, because if I do that, these two cancel out. And I get v initial x is equal to 10 cosine of 25. And if we plug that into our calculators, we should get that v initial x is, that's my brain on calculator mode, 9.063 meters per second. All right. Okay, now let's solve b over here, because I ran out of space. Right? So for b, we're trying to find, in this scenario, v sub y. Right there, v initial y. Okay, this initial because it's the beginning of the actual launch. So in order to solve that, we see that we have the opposite side, and we have the hypotenuse. And so that reminds me of SOHCAHTOA. We have sine is equal to the opposite over the hypotenuse. Okay, so I'm going to set up my equation like this. Sine of theta is equal to opposite over the hypotenuse. And if we put in our data, we have sine of 25 is equal to the opposite, which is v initial y, over 10. Okay, at this point we can multiply both sides by 10, and we get v initial y, I'm just swinging that variable over to the left because that's what I like for my solve variable to be on the left. And if we plug that into our calculators, we get 4.26. Uh-oh, there should be a 2 right there. Meters per second. Okay, congratulations! You solved for v initial x and v initial y.